Hey Wild, in the previous tutorial we have been looking how to read the data from the microcontroller using Python and how to have a graphic interface. But generally speaking, reading the data that way was just with no control on the microcontroller, and sometimes can be a little bit frustrating. So this time we're going to use Python to have a more systematic or control on the microcontroller. So first of all, we will have the option appear only when we put the connect, and you can see we will be able to toggle the pin, whatever the pin, but this one is just the one on the board, and also control when reading or not. So here you can see I'm moving the potentiometer, but nothing happened. And after I put start reading, the microcontroller will start reading, and then I can put stop. So if you would like to learn how to use the GUI and controlling the using Python and controlling your microcontroller, this is the right tutorial for you guys. This is a video tutorial, and at the opposite of the previous videos, this tutorial will be focusing on organizing and structuring the communication between the PC and the microcontroller. So in the previous time, what we have done is just reading the data directly from the microcontroller into the PC without really controlling nothing else. So this time we're going to use two examples to control a pin status and also reading the data from the ADC. And as usual, the code is available on GitHub, so you just follow the video and you don't need really to type. Also, the language that we are going to use is C and Python, so we are going to use both. Even the level is a little bit intermediate level. I will go through the details and try to explain as much as possible the code so you don't feel really lost within, even if you feel a little bit advanced code. Okay, so for the hardware, as usual, the STM32F1 or the aka Blue Pill. Also, we are going to use the FTDI to allow the UART or the serial communication with the PC. And finally, a variable resistance or a potentiometer to have the example and see how the variation of the voltage. Okay, so for the tutorial, we do have at the beginning a quick code review. So for people who just watching this video, at least to know the background of the code we have created in the previous tutorials, and you will understand quickly. So that will be a quick review. Then we are going to set up the control, the pin control, and that will be at the Python level or the PC level. After that, we are going to set up on the other side at the MCU or the microcontroller. So we will be using the C code, and I hope I will be explaining this in details. Then 4 and 5 will be how to set up the ADC reading from the Python side and the MCU side. Okay, so before we jump to the code and explaining it, let's have a quick circuit review. So first of all, we will have the microcontroller. Here, this is the STM32F1 Blue Pill, and it will be connected to potentiometer. So we will be playing with the potentiometer, and as we play with the potentiometer, the microcontroller will be sending the data through a serial or UART FTDI to the PC. So just a note for everyone, if you do have an Arduino or something that a circuit that have FTDI already included, you don't need to add this element. Okay, so from the PC perspective, where we are going to use the Python, then we will have threads to control that. And in Python threads, that's a kind of a parallel computing. It's not a purely a parallel, but it's a kind of a parallel computing because, so first we will have our main thread, and this is will just managing our GUI. And we will see it later on, you don't worry. So this is the normal thread when you run your normal Python code. And this will control just the bottom, the appearance of the GUI. But after that, for reading the data from the UART, we are going to use a second thread. And why a second thread? Because if we just skip reading that, it will overwhelm the main thread and you will be having a frozen GUI and you will not be able to use nothing. And most of that, plus on top of that, a third thread where we are going to update the GUI because when we have done in the previous tutorial, and you can take a look, it's really detailed. When we are going to move the potentiometer, there will be some animation in the GUI. And this is the third thread that will be managing this. So knowing all of this and understanding that we went through all of that, let's go and take a look on the code that we have written before. So here side by side both programs we have been creating in the previous tutorial. So the first one here, the in white, is the program that we use to load in the microcontroller and written in C. So we are going to need only two variables. So before that, three libraries we have created in the previous tutorial. So you can take a look on them. I also added a link. And also these two variables. The first one is a array of char, or what we call a string, and this is that you are going to use to convert to an integer. And the second one is a integer value that we will be reading from the ADC. So first we are going to read the ADC value and then convert it to it. Quickly, the SysTick init is the one that will initiate delay function, and this is we need it inside other function like the UART and the ADC. So I initiate the delay ms function, and it will generate a small delay. And after that, we do have the UART init, and this is the UART initiation function, so that it will initiate UART number 2 and the baud rate of 115,200. After that, we are going to initiate the ADC, or we are going to use the ADC1 and the port A and the pin number 0. Okay, so quickly then, we are going to check each time. So this is the while loop of our main program, and we are going to check if we do have a reading or the reading has been complete. So within this program, the microcontroller will be reading all the time the data, all the time. But there is a kind of like in the life or within the time of the microcontroller itself, it takes a lot of time to read the ADC. So it's some microseconds, but for the microcontroller, it can be hours like inside it. So if you take it in a relative way. So each time to not getting in a loop and keep waiting. So it will be running, and each time I do have ready data. So what I will have to do, first of all, I will be reading the data. This is getting the data or the ADC data. After that, we have to convert this data to a string. So what we are going to do is to put this integer value inside the string or the numerical string. After that, we are going to use the UART using UART2 and send the string. Empty the string because we need to empty it, else it will be keeping piling up on it. Then sending the end line, which is or the new line, which is a signal for the Python to say, okay, we have sent the data, so you can start your roll. That's a very simple program. So first step, initialization. Second step, reading the data when it is ready and send it. So here, this is our Python program. And just to make things simpler, let's run the code. So this is the simple GUI when you just run the Python, and we will take a look on it quickly. So this is the Python, and we divide it in many functions. So the first one, the signal handler, this one, are just you can forget about them. This is really to manage the threading that we do have, because when you run threading within Python, it can generate some issues. So better to put some signal to manage this. And then graphic is a class or an object, and that the class will manage this animation here that we will see later on. After that, the connect menu init. This function is just to initialize this menu. It's quite a simple one where you put the name of each element that you are going to need, and that's an initialization. Then this baud rate select is just a function that will generate a list of baud rate. I put it as a function. It can be just put it with something in it, but just I put it here for make easy to understand code. After that, update com is a quite interesting function because that's a function that looks for all the com connected to the PC and find this one. And let's keep it like this for the moment. After that, we do have the read serial. We will forget about this function for the moment, but this is the function that reads the data from the microcontroller. After that, so we do have the connection, and for the connection, this function is you see here the connect button is not working, and because it's disabled. So if I select this one and select the baud rate, then I can click into connect. And that's quite a very important thing. So after that, for the connection is when I push this button, and connection function will call the serial, where is the serial one, the serial read. So when I push this one, my Python program will start reading. So this is the code. So let me first, yeah, and we do have this is our microcontroller, and this is the potentiometer. Let's load the code. So let's just save, build, and load. after that, let's connect and see what will happen. So you can see I'm having some value appearing and some position. And when I start moving, you can see is moving accordingly. And this is our main program. So I hope you got it about it. So this is the code that we created in the previous tutorials, where you can have a simple animation based on the value of the potentiometer. So this is the part where we start controlling the pin level between low and high. And so we are going to send the data from the PC using the main thread to the MCU through the SEDI. And within this part, the Python will generate a message and send it. And we are going to structure this message so we can make this work perfectly. So the message structure will be as below. So first of all, we are going to send a 0 or 1 to say we are going to change the pin level to low or high. Then see the port name, and after that, the pin number of the port. Finally, we are going to add the terminator, which is not a movie, and which is the /n or the new line to the microcontroller. Based on that, we are going to put some logic in the microcontroller so we can see how this code is working. So let's take a look on how this function is going to change. So as here at the right side, we have the old code and the left side is a new code. And let me drive you to the changes we applied for the code to start making this update. First of all, just change it to root geometry from 500 by 500 here to 800 by 600, as we will need a little bit more space and because we are adding further buttons. After that, first thing, which is a little bit more useful thing, is to remove the graph. So this grid remove for the graph that we do have or the dynamic canvas that we use will not really delete it from the memory, but it just hide it. And what is good with this function is that it will keep reading, keep, how to say, on in memory the grid parameters we put it previously. After that, so here we used to have just the grid and that's all. Then we are going to add, and this is which is our previous code ends. At the end of that code, we are going to add, let me make it bigger here, a new button, which is the toggle pin button. And within this button, which have pin high at the beginning, and after that, it will call a command toggle pin. We will take a look later on the toggle pin, but we are adding a button here. And let me run the code for it and show you the graph. So right now we don't see nothing, and we will discover, but you can see everything is hidden within this graph. Okay. So after that, let me back again. If we go to the previous code for the connection, we just start by saying, okay, if my text is disconnect, then we will do something that will disconnect. Else, we will start the connection and start the read serial, which is just start reading the data for the ADC. However, if we go here and we take a look on how things are going, so we stopped the part where we are going to read the data immediately, which is not the thing that we need. And what we are going to do is, well, actually we comment everything and we start showing the toggle pin. So when I will connect, as you can see here, when I push connect, I will see the pin high here. And you can see again too, if I click on disconnect, we should see the pin, the toggle pin button disappear. Okay, so that's the first part. After that, let's go to the toggle pin function, which is a little bit here on the top and doesn't exist within this code. So within this toggle pin, what you can see is that, first of all, if my pin high, we print pin high just for debugging purposes. And after that, we get a message and which have one, which means I would like the level high. And after that, port C and pin 13 to, and after that, new line, or to say that's the end of my message. And after that, send it. But careful, guys, you have to put a dot encode else you will have a trouble sending this one. And this is to move from a Python string to the string, a kind of a not binary string, but one made of chars, and changing the pin name from pin high and pin low. And if we are not pin high, we are going to pin low because we are sending a command to set the pin low. And after that, the pin off message will be the 0C13/N and send also with the encode. And after that, toggle the name of the pin. If we go here again and push this button, we will have this pin high and the pin name will change as soon as you push on this toggle. So far, simple and easy. So let's go then to the C code and take a look at how things are going on. First of all, I'm commenting this help function and UART function because I'm adding them directly in the message function, and this is the function that will manage the reception. Then there is a library related to UART that I'm using at its full potential. And if you are interested to see how we set up all this, there's a video detailing really all the steps that we have made. As we are going to use here interrupts. Yes, we are going to use interrupts because it's important to minimize the impact of keep waiting for the data. We are not going to wait for the data, but generate a signal each time we receive interrupt data. So this is the UART manager, which is the array that we do have here. And we're going to read few examples, like, sorry, not few examples, few details to understand more. So this table is used with these parameters. So we are going to focus on the signal, on terminator and terminator char. So the signal means that my message is complete and I can start using it. Terminator is the option where I choose it's equal to 1, then I will be receiving a message based on a terminator. 0 is a different thing that we used before for the ESP 8266. We're not going to use here. And terminator char is the defining which char we are going to use to say this is the last char I should receive before saying that this is the whole message. Okay? And then let's go at the end when you can see I have set up the UART IRQ handler, and this is the function that will manage and read everything. Okay, good. So after that, quite very simple and easy. Says take UART init, which is totally normal, and inside the UART init, you do have the whole activation of the IRQ. And finally, the digital output, as we are going to blink the LED inside the board, which is the port C pin number 30. Then at the end, what we are going to do, our main program, first of all, if we do have a signal, so if this one is equal to 1, and this will be equal to that as soon as we found out there is this terminator here. So what we are going to do, first of all, put it 0, so we don't get again within this loop. And after that, reading the data or the message that we are going to use, because every message that is sent will be written here. After that, we are going to empty the message so we can receive again. So let's take a look on this pin on off that we are going to use. So this one is inside the message drive. Inside this one is very simple. So this one would check if message is like the first char of the message is equal to 1 or equal to 0, because this is a controlling for the pins. And then, so we get then the port from the message 1. And as we have seen together on the code that we have sent inside the Python, let's go back again. So this is the code. We are going to send first, this is high or low, and after that, the port number or the port name. So this kind of a double check. If this is not a port, this is not a port that already characterized or defined, which is here, get port. But if it's A, B, or C to return the number here, then it will not enter the loop and mess with it. If it's good, and this function would return, as you can see here, moment, get port, it will return a port if it's correct char, else it would return 0. And after that, we get the level. So message 0. So the first character of this message is 0, but this is a char. And if we would like to have the right, the number, not the char, we have to put minus 48 or the 32 hexadecimal if I'm correct. Okay, and we just run our normal function, which is the write eng. So we get the port from the UART message 1 and then get the pin from the UART message also 2. So the get the pin function is also a small function that will read based on the specific location. And finally, level 0 or 1. And return 1 means everything is good, because we can use this function later on as even with a kind of conditional if you would like to have more sophisticated response from the microcontroller. And that's all. So this is the function. It will read, it will carefully read the message and change it. After that, the best thing to do is just to write and take a look on how the code works. Okay, so this is the microcontroller here. You can see that we do have the LED low. This is the LED low because it's a this is the pin is made like this. So if I put it high, it will stop. If I put it low, it will be high again. As you can see, this is toggling with no issue and working quite properly. So we have seen how to toggle a pin using Python and also how to interpret it using C. So this is the previous way where we created a message. So you can guess now if we would like to set up the ADC reading, we are going to use the same logic. So the PC will send the data to the FTTI to the microcontroller. However, this time it's a bidirectional communication. So the message that the PC will be sending will be like this. So exactly almost same as the previous one. So at the beginning, here it will be A to say, hey, we are going to enable the ADC or checking the ADC mode. And this is a port name and then the pin number. After that, so we add if we would like to start or stop the ADC, then finally the terminator. So this is a logic, and we are going now to check how this will go to work. Let's get back to our program, and as usual, the one on the right is the old program we had made in the previous video, and the one on the left is the new one that we added some update. So if I go to the end here to check my program, you can see I added here, compared to this one where I do not have, added the get ADC button. So let's make this one bigger, and you will see on this one, this is a get ADC, a button that will I will call a command called get ADC, and also we will put it in the row number 5, but we are going to remove. And this is because as far as we are not connected, we don't need to show this button. After that, let's take a look at how we updated the connection function, which is one of the main functions that you have. Let's go to connection here and start take a look on it. So for this one, let's start by the else where we are going to connect. I added here at the end the graph, the canvas and the ADC button. So when we connect, we add this one, and when we disconnect, we remove them. So let's run the program quickly to see what's going on by running this. So if I go this one and choose this portrait and connect, you can see my pin high button that we checked later on previously, and the start ADC and also the animation for the canvas. So let's disconnect and close and go after that. So this is quite a very simple one, but we still have threading, and this threading is the one that will be reading all the ADC data. So let's go up and we put everything on the get ADC, which is here. So this get ADC, which is totally not in this function, so we can get more space here. So the get ADC will be focusing on, first of all, checking if it's get ADC, then it will ask here to stop ADC or toggle what is written, print ADC just to see it from the terminal perspective, and then it will send this message, which is pin on, A for analog, the A, port A, 0, 0 means for the pin 0. So I would like to have the pin 0 as analog pin and start the reading. And then after that, encoding the code, encoding the message, so it will become an array of char and can be read by the microcontroller. And put serial true means this is for the loop on the threading and start the reading. After that, if we do not read, so we do have the ADC off written, so we toggle and we put serial data false. After that, we send a message to the microcontroller saying that we would like to stop, and so the stop is, so this one should be 0, not 1 actually, and we stopped reading the data and we send it. And that's all. This is what we would like to actually it's not B, this one is A. Okay, and by stopping this one, so we can start the toggling this one, and we do have this one like here to stop the animation. So we have taken a look to how the Python will be sending the data. Now we can jump to the to Kale and check what's going on. So if we go here, first of all, I would like to share with you, I added this GUI control variable. This GUI control variable will control a very important element, which is reading the ADC and send it. So what will happen when we will have a signal as we have seen and we get the message. So as this one is a pin on or off will be as we've seen here. Where is it? So this is a pin on off. We'll have some checking on this one. Yeah, it will check if it's 0 or 1, then it will accept, else it will return 0, so it will not care. Then it will jump to this ADC on off function, and in an on off function they will check if the first char of this array is equal to A, so it will go inside and manage the ADC communication. And that's what we'll do, and we will get inside it later on. So if it go inside it, it will return the number here, 0 or 1, that will control the reading the data and sending it. So let's go quickly here. So first of all, get the port is exactly the same function. And after that, you check if it's equal to 1 or equal to 0. So if it's equal to 1, then it will start and initiate the ADC. And that's what we will do. So that's why also we put it here. So let me see. First, we put it here, the ADC libraries. Don't need to have it inside here, and that's why it's commented. After that, after reading that, we will initiate and putting GUI control the first digit to 1. So we can start the loop of the reading and sending. Else, if it's equal to 0, we put the loop control here to 0, and then it will not be reading anymore, and it will stop this loop that is reading the data and then sending it as a basic message. So you can see here basic message function, which is very simple, just controlling it's a function we together. It's the one changing the integer to char or the string. After that, send the UART for the string, and finally you go and send it the /n, which is a terminator that we will use for the Python, as we have seen in the previous video example. Okay, so we have seen all how this is working. I think it's a good time to start seeing the code how it works. So let's go. I think it's ready running. I know we closed it. Let's go and open it. We are reading COM3, and this is serial that the baud rate that we need. We are going to connect, and better to put the camera on. So that's perfect. So let's change. We can toggle, and let's start the reading. So you can see here I'm moving this one, and I can change. So let's stop. You can see it's not moving anymore from the graphic perspective. I can still play as I want with toggling the pin, and also running and playing with this one. So you can see both are working perfectly. And also just to let you know, this is a very simple example, but you can expand the pin because this one is only one pin. You can add whatever the pin with this configuration that we've created, and also whatever the ADC depending on the channel. So by reading here, now this is starting. So now I'm starting back, and you can see everything is working well. I hope you enjoyed your video and you could find it useful, and see you in the next one. Bye.